Okay, finishing up these notes. We started talking yesterday, right before the bell rang, about if a factor has an even exponent versus if it has an odd exponent, how that's going to affect the graph. Whether it's going to the graph is just going to cross through the x-axis, or whether it's just going to touch the x-axis and go back where it came from. Okay, so we're going to go ahead and look at example 6 and kind of make sense of all this. They ask us to do several things on example 6. They asked us to state the degree and list the zeros of this function. And then we're going to state the multiplicity of each zero. And then we're going to talk about whether the graph crosses the x-axis at the corresponding x-intercepts or not. And finally, we're going to sketch it. When I say sketch it, that's not necessarily pulling it up on the calculator. I mean, we'll look at it on the calculator eventually, but that's using what we know here. Okay? So, okay, let's talk degree. Thoughts on the degree? No?
Square.
No?
So the fifth?
Why fifth?
Oh my gosh, because you have to multiply those two.
Yeah. If, and here's the good news, we don't have to multiply it out, okay? We actually know more by just looking at this equation here, but if you were to multiply this out, x plus 2 to the third and x minus 1 to the second, this would be x to the third, this would be x to the second, and then we multiply x to the third times x to the second, you're going to have x to the fifth. So do we see why it's degree 5?
Yeah.
Basically, you're looking at all of your exponents and adding them up. Okay? Now, let's talk about zeros. What about zeros?
4.
No.
Where'd you get 4? Because
No.
5 minus 1 is 4.
Okay, so I'm not talking about how many zeros there are. I'm talking about what are the zeros. Okay? Now, and technically, if you go back and read the rule, if it's degree 5, there can be up to 5 zeros. Okay, there may not be 5 zeros, but there can be up to 5 zeros.
This one is like factor.
Look at this equation. This equation tells me where zeros are, just by looking. Why negative 2 and positive 1? Yeah. If we take x plus 2 and set equal to 0, what are you going to get? You're going to get negative 2. If you take x minus 1 and set equal to 0, what are we going to get? So we're going to have zeros at x equals negative 2 and x equals 1. And if you want, that's because it would be x plus 2 equals 0 and x minus 1 equals 0. I don't really feel like I need to write that. I feel like once you guys see that, you're like, oh, okay, yeah, I got that. Now, okay, after zeros, it asks us, and this is where we're going to have to talk about it, to state the multiplicity of each of these. Okay? Now, we talked yesterday very briefly about multiplicity, and it says if the power on the factoring or the multiplicity is even or is odd. So multiplicity is the power on the factoring. X equals negative 2 came from this factor of x plus 2, yes? What was the power on that factor? 3. So this 0 has a multiplicity of 3. So the 0 of x equals negative 2 has a multiplicity of 3. X equals 1. What kind of multiplicity does it have?
2.
It has a multiplicity of 2 because it came from the factor x minus 1, which has a multiplicity of 2. Okay? Are you with me on where multiplicity came from? And that's what we talked about that last year in Algebra 2, I'm pretty sure. Again, not saying we remember it, just that was part of our lesson stuff. Now we're going to talk about at each of these x-intercepts. This is why we haven't graphed it right now. Does the graph cross the x-axis or does it not cross? And then it would just touch. In order to determine this, look at your multiplicities. Is the multiplicity even or odd? So a multiplicity of 3. What do you know about the number 3? It is odd. What do you know about the multiplicity of 2? It's even. And again, I'm not asking about the 0. I'm asking about the multiplicity, yes? So when the multiplicity is odd, okay, the graph will cross the x-axis. So when I go to graph this here in a little bit, my graph is going to cross the x-axis at -2. Now the multiplicity is 3, but we're going to cross the x-axis. So I'm writing crosses at x equals -2. And that's because it is an odd multiplicity. What does even multiplicity say?
They don't touch at 2.
Even multiplicity says the graph is just going to touch the x-axis at that point. What is the point we're touching at?
1.
The intercept of 1. So my graph is going to touch at x equals 1. And that's because it's an even multiplicity. Okay? Now, again, in order to sketch this graph, yes, we'll look at the calculator here at the end. But what I want to do is, okay, pull all the information together that we can here. And think about, we talked about end behavior on the previous page, yes? It was, yeah, previous page. What degree is this problem going to be?
5.
It's degree 5. What do you know about 5? If something has a degree 5. What kind of number is 5?
Odd.
It's odd, yes? So if the degree is odd, and I know it doesn't ask for this, but I'm trying to get you guys to think through it. What kind of end behavior do we have? And just use up and down type words. If it's odd, and I guess the other thing we need to talk about is that lead coefficient going to be positive or negative. If I multiply this all out, if I multiply x plus 2 times x plus 2 times x plus 2 times x minus 1 times x minus 1, that first term that's going to have x to the 5th, is it going to be positive or negative?
Positive.
Positive because I'm only multiplying positive x's out, right? To get my front, that's all I care about is the lead coefficient. So this is going to be a positive lead coefficient.
Is that the same for all values? Or does it just matter what the x is?
It's because we're multiplying x, these 5 x's together that are all positive. Because my lead term is positive here. Now, odd degree, positive lead coefficient. Both sides go up. Do we have an up and a down? Down and an up? Down, down? What's my graph look like?
Down. Or left side's down. Right side.
Okay, down and up. The idea, if I go back to here, excuse me, right here, this was an odd degree and a positive coefficient. What did it do? It went down and up. So what's this x to the 5th graph going to do? It's going to go down and up. Okay, so that helps me as I draw my graph here. Okay, again, they didn't ask for this, I know, but it's going to help me as I draw my graph. The other thing we've kind of talked about a little bit in this lesson, could you find your y-intercept pretty easily? How do we find a y-intercept? 0 in for x, yes? So if I plug 0 in for x, so f of 0, 0 plus 2 to the 3rd, 0 minus 1 to the 2nd, what are we going to have there? 2 to the 3rd and Negative 1 to the second. 2 to the third is 8. Negative 1 to the second. 1. 8 times 1 is 8. Again, helpful information that I'm going to have a y-intercept at 8. Or in other words, f of 0 equals 8. Now, again, you can pull it up on the graph here in a moment. But if we just sketch this graph based on what we just know here, and it's not going to be precise here, but we have zeros at negative 2 and 1. Zeros at negative 2 and 1. We talked about we're going to have a y-intercept as 8. I don't think I know any other information than that, but okay. Ready to put this graph together? My graph has zeros at negative 2 and 1. So somehow or another, my graph is going to intersect at negative 2 and 1, yes? Okay, that's something I know. My graph at negative 2, it's actually going to cross the x-axis, isn't it? Well, okay, hold on. Before we talk cross, what was my end behavior going to be? It's going to be going down over here and up over here. Yes, that's just my generic, like, okay, there's my brain thinking. My graph has to start down here, end over here. Now, it's going to cross at negative 2, so it's going to have this kind of movement at negative 2, yes? What's it going to do at 1? It's going to touch. Now, it's either going to touch and go back up, or it's going to touch and go back down. In other words, wherever it is, it's going to touch and go that direction. It's not going to actually cross through there. Based on the fact that this is going up here, it's going to have to, I don't like the way I drew that, but it's going to have to do a touch like that. And what else do we know? We had a y-intercept at 8, so I know my graph has to cross here. Are you putting all these pieces together? Okay. I guess the one thing I forgot about, okay. I don't know that I can really fix that right now without totally. Now, I'm not saying my graph's going to look exactly like that, but is that going to give me the ballpark shape? And it does. Okay. Now, one thing I will say that I kind of forgot about, when you, at negative 2, what was our multiplicity? At negative 2, we had a multiplicity of 3. The higher that multiplicity is, the more the graph flattens out here. And so as we go through here, this graph, it's not just going to cross straight through. It's going to kind of, I don't know if I can, it's going to kind of jog a little bit. I don't know. Have you looked down on the calculator yet?
Yeah, it does.
Okay, it's hard to explain a little bit there, but if you pull it up on the calculator, there's going to be a little jog there, and that is because the higher the multiplicity, the more the graph kind of flattens out there. We have x plus 2 to the third, parentheses, x minus 1 to the second. We got the general shape of the graph? We do. You can kind of see right there, it kind of flattens out. I kind of forgot about that as I was going through, but the idea here, I don't know, I didn't want to erase there, but it's going to bug me that so the idea that the graph will kind of It jogs there, it flattens out a little bit, and that is because of the higher multiplicity. You do something like a multiplicity, a higher multiplicity than that, it's going to change even more. Curious, could I? Okay. Okay, for some reason it didn't come back down.
You have 9.
Right, but that was just, what I was trying to show is that at 9, notice my graph flattens out even more, but it should still come back to 1, and it didn't. I don't know. I was totally trying to do that without any, knowing of what it's going to do. Okay. To get out of this, be able to find the degree. Look at, if you multiply this out, what would be that highest power? Zeros. Setting each factor equal to 0. Okay? Multiplicity, that's your power on each factor. Okay? These are what we call repeated zeros. Okay? There's technically still 5 zeros here. It's just they're repeated. Okay? And then knowing if the multiplicity is odd, the graph's still going to cross there. If the multiplicity is even, it's going to touch instead of cross. Okay? All important information you need to be able to pull together. The idea is the more we know about this graph, the more we can do on our own before looking at the calculator. Okay? Okay. If you don't have questions there, let's look at example 7. Example 7 talks about zooming to uncover hidden behavior. Okay? In example 7, it asks us to find all real zeros of this function. Notice it talks about zooming, right? What's our hint here then?
Z-box.
Calculator. Z-box is going to be a good one when I get there. Okay? This is looking at it graphing. So notice it does say all real zeros here. So keep that in mind. Zeros means I'm looking for my x-intercepts, right? So have you plugged this into the calculator? I would definitely encourage you to practice. Type carefully, don't make mistakes. Okay. Hopefully our graphs look something alike. How many zeros do you think we have here?
4.
There's definitely a possibility of 4, yes. Because this is a power of 4, yes. So we can have at most 4 zeros. Are we guaranteed to have 4? Not necessarily, but if you start looking here, do you see the possibility of 4? Yeah. Now, with that in mind, can we find the first one pretty easily? How do we find zeros?
Isn't it where it crosses?
Yeah. And remember, you can use your second calc and go to number 2, 0. Now, on that one, if we start the one on the left, you could zoom in, but you have to zoom in for it. No. So if you need a charge, you just put it in there. It should charge. If we put that in there, there's my left bound because this graph came from above, yes? So left bound is going to be above it, enter. My right bound, as I'm moving down, it crosses, so there's my right bound. The guess, you're not going to be able to get right on there, are you? It just doesn't work. So your first 0 is?
3.
negative 3 point. Looks like I have 2 decimal places in mine. So the 0.9, the 9's going to tell the 0.9 to go up to a 10. Okay, that's the first one. Now, my recommendation. It's really hard to see what's going on in that other half, isn't it? My recommendation is you zoom in on that area so that you can see where your left bound and right bound are a little bit easier. Not saying you couldn't do it like this. I don't know, did you guys try it? I just think it's going to be hard to figure out where your left bound, right bound are. By the way, guys, before I go off this screen, what is that y value there? Negative 6e, negative 12? That's basically 0, yes? Okay, I keep having some problems on tests and stuff with that. But that's negative 6 times 10 to the negative 12. So that's 0.0000, a whole bunch of zeros, and then the 6. That's basically 0. Okay, why they don't say 0 here, I don't know, but it is. Okay, to zoom in, I do like the idea of Z-box because I want to see what's going on over in that little section. Do I need to see the one we just found? No. I just want to see that little piece of the graph right there is all I need to see. So I'm going to zoom in. Do I indeed have 3 more zeros? Yeah, so it's going to be a total of 0. So find your zeros. You know how to do this, yes? Go to 0. Left bound, so if I go to farthest left, I'm below the graph. Enter. Right bound is above it. And, ooh, we have a nice neat one. 0.5. Okay, keep going. Find the next 0. Left bound is going to be above it. Right bound is going to be below it. Right there in the middle. .13. X is approximately 1.13, and whatever that last one is. Find your 0. My left bound is below it. My right bound is above it, because I want where it crosses the x-axis between those vertical lines. 1.366. 6 tells the 6 to push up to a 7. 1.37. Okay. Graph looks something like that, right?
Yeah.
You have 1, 2, 3, and 4 of them right there. So. Okay, questions there? Okay, one more to look at.
There was someone peeking.
Should I peek back at them?
They left.
Probably because we're actually doing something. We're teaching. Okay. Example 8. We ready? Write the cubic function given the zeros of negative 4, 5, and 2. Cubic function given the zeros of negative 4, 5, and 2. Thoughts?
X plus 4, X minus 5, X minus 2.
If these are the zeros, what do they look like in an equation? Negative 4 comes from the parentheses x plus 4, yes? What does an answer of 5 usually come from? It comes from x minus 5. And what does an answer of 2 come from? X minus 2. Now officially they said function, so I'm going to write f of x equals But the idea here is if I take this equation and set it equal to 0, each of those pieces equal to 0, would I find these zeros? We would. Okay. My answer key has this answer multiplied out. I'm getting some looks. Okay. Because it does. Okay. So how would we multiply this out?
We do the first two and then we do the third one.
Okay. Pick 2, multiply 2 of them, and then multiply the third. So if we multiply the first 2, x plus 4 times x minus 5 is going to be?
X squared
X squared, x times x. What else?
minus 5x
Minus 5x
plus 4x
plus 4x
minus 20.
minus 20.
So that's
We still have the x minus 2 I'm going to write down. Could we clean that up a little bit before we actually... And you could have maybe written it down in the cleaned up version. But this is x squared minus x minus 20 times x minus 2. Me personally, when I do this next part, I'm going to distribute x and then distribute the negative 2. I don't know, maybe that's just the way my brain works best. But that's what I find easiest, is if I distribute the x first to everybody. So that's going to be x cubed minus x squared minus 20x. And then if I distribute the negative 2. Negative 2x squared plus 2x and plus 40. Clean up. I see x to the third. Minus 3x squared. Minus 18x and plus 40. Barney made no mistakes. Good news, I matched my own answer key. Okay. Okay, guys, you have a little bit of work time. Use it. Page 188, it's 2 through 8 evens. 9 through 12 is all. That's the one section, it's not just evens. 18 through 28 evens, 34 to 54 evens.